My name is Mark Lindeman. I'm with Materials and Research in NDOT in the Geotech section. And I also wanted to note that Benish did the geotech work for us, the analysis and the reports and the plans. Brandon Desch is here also if you have additional questions. I was going to mention too that my slide format kind of follows our D sheets in the plan, and I may be going through a little bit more detail than some of the other groups, and if I'm going too fast, let me know. So, begin with, I'm going to talk about just a general project geology, a little bit about bridge foundations, our embankments. We've got a lot of earthwork on this job, and as Steve mentioned earlier, we've got some over-X, quite a bit of over-X on the project, some settlement and paving delays, as well as foundation delays, along with those paving delays. A lot of retaining walls, some of those sections where we've got the need for ground improvement, and instrumentation also along the embankments and near the MSE walls, and some notes on some grading too, the soil types present on the project. So I'm kind of breaking down things by section, and kind of Steve did before, starting at just talking a little bit about the geology. This is just generalized, but the west section, the north section where we're at here, at the building we're at here, it's mostly less Peoria and Loveland soils over shale and sandstone. There are some alluvial clays at a few locations. The southern portion of Highway 77, it's mostly less over glacial till. And then transitioning eastward from the west interchange to main line, we get into the floodplain deposits from Salt Creek, where we have thick deposits of topsoil, subsoil, and some alluvial clays, and then our bedrock, shale, and sandstones. And so this is what I'm calling our west section here. And just kind of highlighting where we have some floodplain deposits where that kind of starts here. This is just generalized again. Middle section, we transition around station 310 from our alluvial clays back to our upland soils or loess over till. Again, you can expect your alluvial clays over loess and till in your drainage ways where we've got our culverts. Just a general area here, transitioning again from west to east, our 27th Street interchange. We've got some thick deposits of some topsoils and some alluvial clays. I'll get into a little bit later. Then the east section, again, we're still in the upland area with some loess and tills. We do have some alluvial soils at the kind of near the 82nd Street area, the wagon train tributary. So there's 98th Street. And heading to the main line on Highway 2 there. Just a little brief discussion about our bridge foundations. As Joel mentioned earlier, they're pretty straightforward. It's H-piles driven to bedrock or firm soil. Note on the plans that we do, on some of the pile, we require pile points. There's lengths provided for CMPs where we have MSE walls. And also the plans note where we have test piles. Just a brief, I'm going to just go quickly. Note that we may need a setup factor or reset pile strike on some of the piles that aren't on the bedrock. This is our typical geotech sheet on the bridge plans. Just pay attention to the where we've got test pile. We'll be doing those. So give our group a call or through the project manager, let us know when we need to get out there. And highlighted too is just an example of the CMP lengths and your pile test data. And also note there's a MSC wall note on the plans too, where we've got those talking about when you can drive pile. Well, some of these sections, some of these bridges, we've got some settlement and paving delays and pile delays. So it's up to the contractor if they want to. Some of these areas either need to be preloaded or ground improved. The contractor can either wait for that to happen and then drive pile before the MSC wall is built, or place CMPs and drive the pile after the wall is built. There's some notes in the plans on that. Not going to go over pile setup. That's all the pile contractors know what that's all about. Over excavation is a big one on this project. In the plans, they're noted either as unsuitably wet, maybe an unstable, unsuitable soil. West half, especially on the floodplains, we've got thick sections of topsoil. Most of the, again, in the floodplains and drainage ways. And a note on the plans also says actual extent and depth required for excavation is going to be determined in the field by the engineer during construction. So that those, these are based on borings, and these may need to be shortened or extended. Typical over-X in the plans shows over-X and replace it with soil. You have the option of using crushed rock, all crushed rock, or crushed concrete, or partially crushed rock and soil. So again, I went into detail on, a little bit more detail on the settlement on the project, and I tried to color code it because I realized, and you guys probably can't see this from the back. Jim, these are going to be provided on the website later. So you can go through and again, these follow the plans too. But, so I kind of tried to highlight major settlement areas and delay periods. The gray is just your standard 60-day delay. For this project, we determined that a delay period of 60 days or less didn't really need a surcharge or anything to expedite the settlement. Where we've got green or double asterisk next to the delay period means that the pile foundations also need to have that delay period before they can be driven. Yellow indicates a mandatory surcharge for wick drains, and then the orange indicates foundation improvements required. So I'm just kind of following along with the plans, some key settlement areas. So the west interchange area, we're actually on the main line here, headed east. Some items of note would be the Salt Creek Bridge approaches and abutments. Got some delay period for the approaches at 115 days. So if you wanted to have your option to surcharge 4 feet, that would reduce your delay period to 60 days. That's highlighted by these kind of blue rows here. You'll note at the abutments for Salt Creek, a mandatory surcharge is required of 8 feet to get the delay period down to 60 days. Continuing further, again, we're at the Jamaica Trail area. Mandatory surcharge here, reduce your delay period from 125 days to 60. Got around 13.5 inches of settlement at these abutments. Continuing east, this is near the 27th Street interchange. And then I'll also talk about 68th Street and 84th Street, 54th Street as well. BNSF Road, or BNSF Railroad bridges, 125 paving delay. Includes bridges as well, foundations. Nothing mandatory as far as surcharge or wick drains, but those recommendations are provided if you want for the abutment 1, 5-foot surcharge would reduce that delay period to 60, but at abutment 2, To get that 60 days, you need quick drains also. Here, it's near a large boxes east of 84th Street in 60 days using a 6-foot surcharge, but that's optional. Otherwise, we're looking at 180 and 210 days. Continuing, here's near 98th Street and headed towards Highway 2. OPPD bridge, nothing major here, 60-day paving delay, but bridges are also, the foundations for bridges are also included in that. You'll note up at 489.50, that's a large box on a skew drainage way. Got a little bit higher paving delays of 90 and 210 days without surcharge. OPPD bridge, 90 days and 60 days. If you use a surcharge at the abutment 1, you're down to, with just a 2-foot surcharge, you're down to 60 days. Important part of this project and keeping track of all this is instrumentation. These sheets show, provide the details and show the locations of all these. For this section, we've got 21 settlement plates, 2 inclinometers, and 17 piezometers. These will be installed by the contractor and collected. The data will be collected and reported to the geotech section at least weekly. We'll use that to monitor settlement and stability and adjust bank and fill rates if needed. Another item to note is, around instruments that are within the embankment, we require a hand compacted mound around those just to keep them from getting damaged or hit by a scraper. It seems like when you mark them and paint them, this is a target for them, so we're trying to just keep them from getting hit. And also the contractor has the option of installing additional instruments to monitor at their own cost. So we're starting back here on Mainline, going to talk about the west interchange here. Wall X, just to the north of this building here. It's a modular block wall. Soils here are subsoil Peoria, nothing major. Maximum height is 10.5 foot. One thing to note is just make sure you get your shop drawings and calculations and testing of any select granular backfill for your walls submitted, as soon as you can, so we can get those reviewed and turned back into you. So here's our location here. I believe we're right here. So wall X is right there. Settlement on Highway 77 southbound. It's just for a box, a large box fill, 60-day paving delay. So bridge over main line, pretty large settlements here, 15 and 20 inches, 60-day paving delay for the piling as well. Settlement plates for this job, we've got 4 and 3 piezometers. Okay, so now we're in ramp A. So wall P's, again, starting about this building and headed towards under Saltillo Road. It's kind of a unique situation here. We've got a portion of it's cast in place, a portion of it's soil nil wall, and the other portion is MSC. We've got a soil nil wall. Here's our cast in place, kind of in front of right here. Soil nil wall, we're using basically from Apache on past rods outdoor power. We're limited on what we can do as far as excavation and staying out of there right away. And MSC wall extends underneath the bridge here, a little bit past. One thing I wanted to note too, just about looking at the foundation properties provided for the MSC walls, note at what the assumed reinforcement length was. A lot of times you'll see 0.7H or 1H. Those are the reinforcement lengths used to get satisfactory external stability. So you want to make sure that those at a minimum are used in the design for the walls as well. The retaining wall P, the MSE wall portion is going to need overexed sandstone or shale. We're fairly close to bedrock in this location. Ramp B, just on the other side of the roadway here. Wall Q is just cast in place at MSE. No need to do a soil on the wall here. And here's a little discussion about the reinforcement length. I talked about typically you assume a 0.7 H for design, and the plans will note if 1 or 1.2 is used for your height. That height is from the bottom or top of the leveling pad to where the failure surface extends. So essentially for this situation, top of the leveling pad to the roadway, not just from the leveling pad to the top of the wall. We want to take this into account as well. Continue on ramp C. We've got a lot of walls on this section here. Wall U. Here's one where we've got ground improvement required for the east segment of the wall. Here's wall U. General soils for this, clay soils to 18 to 24 feet below ground level. We've got bedrock sandstone below that. And you'll note that ground improvement for this requires less than 3 inches post-construction settlement, and a factory bearing capacity of 7,300 pounds per square foot. One thing to note, pay attention to, or take a look at our special provisions for the ground improvement for these. We're not trying to limit what you do. Some examples could be overex, preload, or combinations of surcharge, whip drains, stone columns, rigid inclusions, or deep soil mixing. Wall W, that's right here. In this section, we're looking at topsoil, subsoil over less, and then sandstones around 22 feet. Again, this one's going to require ground improvement as well. We've got clay soils ranging from 15 to 22 feet below ground, with a loose to medium dense sand layer, and as I mentioned before, sandstone at 22 feet. Here we're looking at, again, settlement less than 3 inches after construction and a factory bearing capacity of 8,700 PSF. Wall T. So this one's next to wall W here. No ground improvement needed here. So some settlement along ramp C, south approach and north approach abutments. We've got pretty large settlement, but only a 60-day paving delay and bridge piling delay. And one piezometer and 2 settlement plates. Ramp D. No big ticket items here. 60-day paving delays and 1 settlement plate. Ramp E. Again, nothing too major here. 60-day paving delay. Ramp F. We've got a wall S, settlement's going to require over-X to get to some good material. And these are all in the D sheets. This is a typical of what the excavation is at this location. And there's your location of wall S. Next one I'm going to talk about is wall R on the opposite side. No over-X required on wall R. Settlement for ramp F, in 60-day paving delays, and 2 settlement plates. Ramp G, we've got wall V that we have on ramp G, and that one's kind of parallel to 77 and the ramp. Settlement for ramp G, 60-day paving delays with the bridge piling as well, and 2 settlement plates. Ramp H, just looking at a 60-day paving delay, 4 inches of settlement, and here we're transitioning to mainline eastbound. West Saltillo Road, just have 60-day paving delays at the approaches. Now we're headed east on main line here. This 27th Street interchange. Here you'll see the orange highlighted area. That's where we're going to have required foundation improvement. Again, this is where we've got a lot of the Salt Creek floodplain deposits, significant settlement and delay periods, and some global stability issues for the MSC wall, so we need to address those with some sort of foundation improvement. So we're talking this bridge here and our ramps, 1, 2, 3, and 4, and we've got some pretty large settlements on the ramps. As Steve said, those don't need to be open as soon as the others. Options are provided though for surcharge and wick cranes to reduce those delay periods. We're looking at some pretty significant settlement amounts here. I think the lowest one is 10 inches here, up to 20 inches. As I mentioned, need some foundation improvement for the MSC walls here. Limit settlement again to less than 3 inches. Bearing capacity 6,200 for wall 27S, and 27N we need 6,100 PSF for factory bearing. There's our 2 wall locations. Again, general geology here. We've got a thick layer of topsoil, 5 foot approximately, and then 25 to 40 foot of pretty variable soils, very soft to stiff, and then 25 to 30 foot layer, loose, very loose to dense, medium dense sands, and then the Dakota Formation. And our ramps have the similar geology as the MSC walls as well. We're going to have some instrumentation at this location too, settlement plates and kilometers and piezometers. 54th Street, looking a little bit better. We're getting out of the floodplain and back into the upland soils. Here we're only looking at 60-day paving delay. We've got 2 retaining walls. Retaining wall 54S, we do have some more over-X. Those are the 2 locations, and then we have 2 settlement plates at this location. 68th Street and its ramps. Yep, just 60-day paving delay, 3 inches of settlement at the abutments. Retaining walls, no ground improvement required. This one's a little more straightforward. There's our wall locations, 68N and 68S, and 2 settlement plates. 84th Street and ramps and loops. You'll note north approach, we've got a 510 day delay period, but you had 6 feet of surcharge that knocked it down to 60, which is pretty reasonable. So this, again, that's optional, but 510 days, that's quite a bit. We've got walls at 84th Street. Again, no issues here. And 3 settlement plates and 1 basometer. 96th Street or the East Saltillo Bridge. Just a delay period of 60 days. Walls don't have any foundation concerns. That's those walls. East into business. Here we've got 210-day paved delays. Ramp 4's got an approach that goes over transitions to OPPD. That's where we're seeing this big delay period. And again, a 5-foot surcharge knocks that down to 60 days. The walls for this location, any highway N and any highway S. And instrumentation, just like a lot of the other locations. And then my final note here is just on the grading. You want to pay attention to the compaction requirements. Where we have fat clays with a liquid limit over 50, we've got different moisture requirements for tolerances. So we're at optimum up to 5%. And then any material that has a liquid limit greater than 50 needs to be within 5 foot below the subgrade. Again, this is to ensure satisfactory performance long term, keep from heat and swell. With that, that's all I've got. Any questions?
Take his question. I'll just ask it. Just seen on other jobs where you've lived, you guys have accepted fat clays 2 foot below pavement subgrade versus the 5 foot.
Yeah, I think it's been three foot in the past.
I mean, are you guys, moving this many yards that's fat clays intermixed in glacial tills? How's that going to be handled? I mean, and also, can't you bump it from 5 foot and drop it down to 2 or 3 foot?
It's something we might consider. We'd have to discuss, and that's something we'll have to discuss. But yeah, we talked about that a little bit.